Now let's talk about the sum rule. So the sum rule is so in this situation, what you have is you have an event, let's say E, right? In the product rule, remember the events, right? They were independent of each other. But now in this case, they're not independent, right? And then they cannot occur simultaneously. So again, event E can occur m ways, and then event F can occur n ways, right? So what are the possible combinations that are allowed? Again, they both cannot occur simultaneously. So the answer to that is m plus n. Instead of a product, you have a sum. That's why it's called the sum rule. And so in this case, what you're doing is, let's say in terms of more technical terms, in terms of sets, if you have if the sets are mutually disjoint, which means that their intersection, like we're essentially saying that their intersection, there are no overlapping elements if the intersection is an empty set. So then the cardinality, the possible combinations is just the sum of the cardinalities of the sets. So what does this mean? Let's go back to that slide that has the menu. So that's it's a bit more intuitive. So let's look at that again. So again, I give an example to students. So let's say that you're on a strict diet, and instead of choosing one out of each, you have to choose one out of all of these, right? So you're on a diet, you're a very strict diet. So you have to choose either coffee, so you have to choose either sausage or either eggs. How many combinations, how many possibilities do you have? So that's obviously, then you have 1, 2, 3, 4, 5, 6, 7, right? Or instead, or now, for this, from the sum rule, you have 2 plus 2 plus 3 instead of 2 times 2 times 3, right? So then you have 7 choices, right? So that's because of that. Now the rule has changed because of this restriction, right? So okay, let's go back now to the previous slide. Sorry, yeah, we were over here. So again, so in that example, so in that example again, you had to choose one out of each of the menus, right? But the sum rule is again, in this case, let's say you have again the same examples of from food, right? You have, let's say, 2 sets. And then there is coffee, hot cocoa, tea, and then the other set is juices. So you have to make choice out of choice out of all of these. So you have to choose one. So obviously you have the cardinality of this set is 3, and of this set is 2. So that means that your possible combinations that you have is 5, right? So that's again because of the sum rule, that the two are not independent of each other, essentially, right? They in a way dependent on each other, because your choices are connected. You have to make a choice out of all of the possibilities of the 2 sets. Okay, so let's look at passwords. So let's look at this example. This is an example that basically uses both the product and the sum rule. So let's say you have to write a password, right? And then you're imposing some restrictions, right? The passwords, the string, right? The password must be a string of length, but 6 should be, the length should be between 6 and 8. Okay. And so the characters that are allowed are lowercase letters and digits. So A to Z, and then 1 to 10. Okay, so we're imposing a restriction of 26 alphabets. So A to Z, there are 26 alphabets. So the cardinality, so there you have 2 sets, right? So this is the letters, right? And then this is the digits. So the cardinality of the set of letters is 26, right? So that's over here, and then the cardinality of the set of the digits is 10. So the total, the possibilities that you have from the sum rule is that you have 36, right, possibilities, and so it's just the sum of the cardinalities of the two sets. And one more thing is that when we say that the length should be between 6 and 8, it means it can be either 6, right, or 7 or 8. So there is an or in between, and let's see what that means. So again, now you have, so remember, let's go back again to the thing we discussed, right? So if you have let's say 2 digits, right, and you want to build a string out of length 3 out of that, then that means that you have 2 to the 3 possibilities. If you have 2 digits, 0 and 1, so I'm just repeating what we did for what we discussed for the simple case, right? Because you have 36, the concept is the same. It's just a bit tricky. You have more, many more characters over here. So for 2 digits, again, the possibilities are 2 to the 3 for strings of length 3, 2 to the 4 for strings of length 4, and so on. So now you have 36 characters, right? So 36 characters means that you have you have again the A to Z and then 1 to 10. So what does it mean that it can be either of length 6 or 7 or 8, right? So what do you mean of length 6? 36 to the 6, right? This is what it means for length to the 6. Again, when you have 2 digits, and if I say I want a string of length 6, you would do 2 to the 6, right? But if you have 36 characters, then that would mean that if you want a string of length 6, then it means that you have 36 to the 6 characters. And then if you say it has to be either length 6 or length 7 or length 8, that means that you have to add for all the possibilities because of that or that you have, right? So you can see there's the number blows up really fast over here, right? So from the product, so this is what we got from the product rule. So if you go back right to the sigma, right, we read sigma to the n, and if it's 2, the cardinality is 2 to the n, right? Over here the cardinality is 36, right? So it's 36 to the n or g. Okay, so over here we have used the product rule, right? And then over here we have used the sum rule because the password can be either 6 or 7 or length 8. Okay, so let me know if you have any questions about this. Go ahead and solve the worksheet.